Hello, everyone. We are really excited to be with you today with Tarak. And we'll be
Hello.
talking, yeah, hello, Tarak. We'll be talking about a lot of things today and really excited to be with you. So I hope that everyone had a good vacation and back to work with full energy. And so let's see what's the future of the cloud infrastructure and what's next. All right. So let's quickly, this is slides about who we are. So I'm Shafiq. I'm the founder of Brainboard, and I'm actually an engineer. I've been building cloud infrastructures for the last 17 years. And I'm here today with Tarak.
Hello, and I'm cloud architect at Brainboard. I've been working on Brainboard for almost 2 years now. Started my cloud journey working on Azure and Terraform, and I've been a growth manager for the past 10 years. Very nice seeing you again.
Yes, and yeah, Tarak, you may know it. You may know him through LinkedIn. He's sharing a lot of technical content and so on. And the reason we are doing it today together is this is the amazing story of Tarak. He comes from a different background. And I wanted him like today to see how Brainboard helped him move into the cloud, into the industry, to the point that he is now sharing a lot of content and technical one and technically accurate. It's for me, it's something really crazy. And he was like initially was a lawyer. And maybe Tarek, you can talk about this, like how you transitioned from being like in a different industry into the cloud with Brainboard.
So basically, I learned everything 2 years ago when I joined Brainboard. So when I joined Brainboard, I knew, of course, what was a cloud and everything, but I never built a cloud infrastructure. Today, thanks to Brainboard, I'm using it myself on a daily basis. I've been able to build cloud infrastructure either on Azure, AWS, and GCP. And I found the platform so easy to use that I've been able to learn and create a lot of videos and help some of you to learn as well Azure, Terraform, and AWS.
Yeah, that's perfect. So here, and we'll be talking today about the future of the cloud infrastructure. We call it design first, code when needed. And so we'll be talking about the legacy workflow, like how we are building cloud infrastructures till today, or maybe, we can analyze the last 10 years of the infrastructure, and then what design first is and why. And we're going to see it in action, this concept in action, because it all started with a wish list with Jeremy, who was my colleagues before starting Brainboard, and how we we put this concept in shape. And we are here to answer our questions and also like have it this technical discussion where we talk about what matters technically and how we solve the challenges we have. So, and actually it all started with a question. I was talking with Tarak about like someone said, hi, I need a cloud infrastructure. And we realized that may sound simple, like, hi, I need the cloud infrastructure. I wanted to understand from this point, hi, I need cloud infrastructure, into here is. This discussion
is very simple, actually, like you said. And I see that you have written spec to provision infrastructure. So can you please detail what are the different steps and why all of these steps matter and what could be the challenges of each of them?
Absolutely. Yeah. This is like the discussion we had, like it should be simple. And it's supposed to be simple. And we wanted to break it down like, okay, what's behind the scenes? What are all the steps that we need to go through to build it? And so then we realized that, okay, we talked to a lot of users, a lot of customers, prospects, and we found a clear pattern, like everyone is more or less doing it the same way. So we all start with the specs. I mean, if you don't have specs, this is another story, maybe a bigger problem. But if we have specs, we usually start with designing these specs with any of the tools that we know, maybe Visio, Draw.io. And this is, you can say, okay, my startup or my company is a small, maybe you don't design, we just write the Terraform code. But a big part of the industry starts with the design. If we look at the enterprise workloads and big companies, large companies, the design is a very important part of it. And once we have this design, we're going to translate it into code, whatever the code, then test it, review it, document it, and so on, and validate it, then deploy it. These are the steps. I mean, you are familiar with these steps. This is what we are doing in the industry till now. And so with the infrastructure as code, I mean, it divided this word into two parts. And this is not new as well. We have the part before having the code, and this may take days, weeks, or months, depends on the speed of the company, velocity of the team, and different factors. And after having the code is just few clicks, and maybe it's automated, the deployment is automatically, it happens automatically and deploys the cloud infrastructure. So these are the steps. And then, Tarek, you remember we were talking about, okay, what if we see what every step needs and what really is about, and do we need a different tools or not? And then we started looking into every step, and we realized that there are three important things, that every step, from what I have seen, needs different tooling. It could be completely different tool, a different learning curve, and this is extremely important, a different way of doing things. So let's first look at the design. So when we design the cloud infrastructure, and with the legacy tools like Visio, Dryo, and so on, by design, it drifts the infrastructure, because usually we depict the high-level design, and we do not track the low-level designs. And yes, Doc.
So one question here: why do you start by design first? Why is the first step in all your process? Why is it important for you?
Absolutely. There are a lot of reasons for it. The first one, that we as humans are visual, and we already know that a picture is worth thousands of words. But besides this, designing the cloud infrastructure, it's the right way to do things, because you start by thinking and understanding what you'll be building before you build it. You can jump into the code directly and start writing the code, but even when you are writing the code, you are designing the infrastructure in your head. Even you design it, you can say, okay, if I talk about AWS, I have this subnet within this VPC. I have this security group here. I have the deployment in this region. So you are already doing this design. I have this, for example, Lambda functions. I have this database here, and you have doing it in this way. And for Azure, the same. For GCP, the same. You can say, for Azure, for example, I have some Lambda. I have some Azure functions that are deployed with a specific resource group within a specific subscription. I have another, let's say, for example, hub and spoke architecture that are split into multi-subscription and so on. So we are visual, and we do this design by design, and this is extremely important. Yes.
One question as well is that you wrote here drift easily. What does it mean, drift, and why it could be challenging?
Absolutely. So it drifts easily because of the nature of the design as we do it today. We usually, when we design the cloud infrastructure today, we just, most of times, we build what is called HLD, high-level design, which means this high-level design, it doesn't track the low-level information that really represent the infrastructure. And we know that the infrastructure is a living organism. It changes faster than we are able to update the design. This is the first point. And it drifts easily because we know that at the time we finish the design, it's already different from the implementation. And this is the second point that I wanted to come to, is that once we design the infrastructure in our workflow, we're going to go into translate it into code, whatever the code. Here is Terraform is the dominant. This is what we are seeing in the industry. And now things are, we have a lot of drama now regarding Terraform and what's happening in the industry, but this is a different story. But Terraform is the dominant. And so once we start writing the Terraform code, we realize that it has a learning curve, because it's completely different than the design. This is something different tooling. And then once we know the Terraform and we know everything, we need some standardizations within the company. We need best practices, and we need a lot of things. And the most important thing is that the review, as of today, is done after we push the code into the repo. So we need, when we finish, we're going to push it, and someone else are going to pick what we have done and is going to analyze it and review it. All right. And this, I mean, okay, we're talking about the code and something, as we are like talking about IaC, infrastructure as code, we already necessarily talk about the tests because we are applying the software principles to the cloud infrastructure. And even in terms of tests, it's again a different mindset, a different way of doing things, a different learning curve, because you have two ways of doing tests. Either do them locally in your laptop, which means you need to install everything, all the things that that you want to test. And for example, if you are if you are testing, for example, for security or for cost management or anything, you need to install these plugins locally on your laptop. You need to maintain them. It's complete stack, and you need to do all this manually. Or if you are testing remotely, you need to trigger, you need to push to trigger the CI pipelines. Some of you may argue, say, okay, we have pre-commit, we use pre-commit, which is a very good concept, by the way. But pre-commit, I mean, it doesn't work on its own. You need to put it in place. You need to maintain it. You need to make sure it's working the way you want, and so on. It's a work. And it's completely different than writing code and completely different than designing the infrastructure. And so once this design, this test happens, laughing because we'll be talking about reviewing and validating the cloud infrastructure. And the one who will review the infrastructure, will he or she review the design or the code or both of them? And we know that looking at the code, we sometimes don't trust it because we know that it doesn't reflect reality. We need to read the code, but for the code, we need to understand what's going on and be able to look at the tests and be able to confidently say, I approve the infrastructure or not. And once this is approved, the deployment is not a problem. You just, it's an automatic way, either when you approve or not. And here, like when we talked to users, we talked to a lot of users, and Tarek especially talked to a lot of users and customers. And when we ask them about automation and workflows, there are two things that comes to their mind: Terraform and CI/CD. And we were like surprised, like, okay, CI/CD is a great way, automation and so on. It helped the industry to move to the next level. This is something really cool about our industry, that we are able to automate a lot of things. But they don't think about building infrastructure as a whole concept, like holistically, including the people working on the infrastructure. And we said, okay, what if we put it in the right way? You asked, Tarek, you asked about design first, why we start with the design. And it's a natural way. Even if you do not design, you're designing it in your head. And at Brainboard, we started like, okay, let's forget the industry and build it as a wish list. What are the things that, as engineers, we want as we build the cloud infrastructures? What are the steps and how we can put them into a system that allow us to go beyond infrastructure as code? So looking at the design, I said, okay, what if we have not a general purpose design system, design platform, but a solution that allows me to design the cloud infrastructure with Terraform and the cloud knowledge? I mean, with all the advancement of technology, and now with AI, we have a lot of capabilities and a lot of things that we can do in terms of infrastructure. And it's really pity to just do things the same way over and over again. I said, okay, what if this designer allows me to build an infrastructure with the cloud and Terraform knowledge? And since we are talking about infrastructure as code, having the Terraform modules built in natively is a great way to really transition and lowering the learning curve, and especially if you have already built something within your organization. And we looked at the code. I said, okay, the code is powerful, and we want to use the code, and we want it to be an integral part of the process. but we want it to be auto-generated. Actually, Terraform is predictable blocks. You have resources, data, variables, the provider, and so on is predictable. Why not generating it on the fly from me? I do not need to repeat myself from design to code. And then with this code, we wanted to take it to the next level and said, okay, let's dream a bit. How about like having an integrated, IaC best practices? What if it gives me the possibility to build standardizations easily and in a way that I don't repeat myself, but I just put my standards within the tool. I see people from Greece and Dubai all over the world. Hi, everyone. I highly appreciate that it's, I think it's after work, 7 p.m. or 9 p.m. in Dubai. Thanks a lot for joining us. So and we talking about the code and said, okay, now this code, of course, since the code is automatically generated, why I don't have the CI/CD platform within the same tool that allows me to shorten the feedback loop? Because this is extremely important. The role of the test is to reduce the feedback loop, to be able to, this is what is called shift left, which means detect what's wrong as early as possible at early stage and fix it. And the most important things that we test in the cloud infrastructure, the first one is security. I mean, we need to understand if we are building secure infrastructure or we have some flaws, and bring this FinOps mindset and awareness. Like, are we building within the budget? Are we over the budget? Do we need to shut down the environment when we don't need it and only use it, turn it on when we use it, and so on? And the other things are management, like, okay, how can I integrate with other systems and so on? And here, this leads us to a very critical point, which is I gate my deployment with review, validation, and approval. And the one who will review and validate and approve or not will have the complete information, like really all what is happening about the cloud infrastructure. They can look at the design, understand it quickly. This design represents faithfully what we have in the code. They can inspect the code. It's not a black box. And they can see the output of all the plugins and executions of the costs, cost estimation, security, and so on, and say, okay, now I take the right decision to approving the infrastructure or not, and I know why I don't approve the cloud infrastructure. Once it's approved, this is easy. As we talked about, provisioning, just click on the button and it's deployed. And this part is just the beginning, because, I mean, since we are talking about automation and how technology is an enabler for what's next, all this is just the first part. And the second part is, okay, once I build a cloud infrastructure and provision it, how about scaling this infrastructure? Especially, I mean, when the company and your team start going bigger, having more workloads and so on. And what's my strategy between the environments? Because we know that, like, we usually have production and non-production. Non-production could be QA, staging, dev, and so on. And it's not just between environments as QA and dev and as prod and non-prod, but also environment for specific teams or specific projects. And so being able to capture the knowledge and the maturity of the cloud infrastructure into a system, not in documentation or in the head of engineers, into a system is critical. And here, like, we look at different verticals, like, okay, how can I create templates for my work? How can I securely store the information, like remove backups and so on? How can I have synced environment in a way that I do not repeat myself from environment into another? Talking about multi-cloud, how can I have like a multi-cloud strategy? Because we have different teams that use different cloud providers and so on, and into even building, and this is really beautiful to see in action, building a serve-serve model where you have producers that build cloud infrastructures, and the consumers, those who use and pick off the shelf the cloud infrastructure and use it. These cloud infrastructure that has been approved, reviewed, validated, and so on. So you put, as I said, this process and this cloud maturity into a system. And these all the discussions that we had with Tarek and the team before, and said, okay, so now this is the wish list. What if we turn it into a product? And here where Brainboard comes into play, and I would be happy to like show you these design first principles and code when needed. And by the way, we will be sharing with you what's coming next. So we have some features, exciting features that we'll be sharing with you guys. So I'm going to share it at the end of the session. So here, like the first thing, as we said, it starts with doing things the right way. So I think about the infrastructure before I just start coding it. And let's take a real like multi-cloud architecture. So here, I'm going to build multi-cloud architecture. And the goal here is to build cloud infrastructures for in AWS and Azure at the same time, and see how this design first, code when needed principle works. And so here, for example, let's start with, for example, let's start with AWS. All right, I'm gonna pick AWS here. So the way I build the cloud infrastructure is exactly the way I think about it. So here I'm gonna take, for example, I'm gonna add a region because I'm going to deploy in a specific region. I can pick from the regions that are available here at AWS or use variables. We'll talk about variabilization later. And here inside my region, I can say, all right, I need to deploy, for example, some networking, VPC. I just search for VPC here and pick from the available here. I'm going to pick my VPC here. And you can see that the Terraform code is generated on the fly as I build the cloud infrastructure. And now I can I have the complete information that are supported by both Terraform and the cloud providers, and I put a valid value here. If I need any option, like I need to enable DNS host names, I just put it true. Enable DNS support, it's true, and that's it. Now I build a cloud infrastructure. I build the first piece of my infrastructure, and I keep going. I see now. Inside my VPC, maybe I have different availability zones, or maybe I'm going to just pick one here. Again, I can use variables or pick from the ones available. And here I can say, okay, inside my this availability zone, I'm going to add a subnet. I'm going to add a subnet here. It works the same as the VPC. And this is the power of the Brainboard engine that has the cloud and Terraform knowledge. So it detected that I'm adding a VPC, a subnet inside this VPC, and adding native Terraform language and inside the availability zone and adding it. And with best practice, so we add by default tags in a function that you can control all the tags that are injected in all resources from one point. And let's give a valid value here. And I keep going. I said, okay, inside now my subnet, I may add, for example, an EC2 instance, or like I just pick an EC2 instance here. Like let's take T3A something, for example. Here I'm going to edit. Then Brainboard detects this action, fills all the information, and I now maybe like MEI123. This is my image, and I pick one of the instances here, instance type medium, for example, or I can say, okay, I'm into Lambda functions or containers. I just pick here Lambda function. This is my Lambda function here. I'm just going to add it into the design and fill the information. This is the function name. This is, for example, my function. And for the role, I can add some roles here and add them, or use the var.lambda IRN here, role IRN. And I can keep building infrastructure this way in a visual way. As you can see, what I build visually, I have a faithful representation in terms of Terraform code. I can keep going. I need storage here. For example, I'll pick S3. So here I'm going to pick an S3 bucket, the same, because maybe my Lambda will get its file from the bucket, for example, here. And I add all the information. And then, for example, for the bucket name, I'm going to use a variable, bucket _ name. Force destroy true, and I have every single parameter that is supported by both Terraform and the cloud providers here. So once I save it, the code will generate it to reflect this. And I can point Lambda function to use S3. I can say here, for example, from the bucket, I'm just going to type bucket. Brainboard will suggest all the valid attributes that I can use from the bucket here. Let's take, for example, bucket ID. So here, Brainboard faithfully depict the relationship between them and build the right code to represent this. I do the same for any cloud provider. I can switch now into Azure. And let's take, for example, here, something in Azure. I'm going to add a location next to AWS and either use a variable. Inside my location, I'm going to add a resource group. I'm going to put the resource group here and call it, for example, design first. All right. And inside my resource group, I'm going to add, for example, some networking. As I did for the VPC, I'm going to add a virtual network. So where is my VNet here? All right, this is my VNet. And Brainboard detects whatever the logic actually of the provider. Brainboard detects the right logic. For example, for AWS, the subnet needs the ID here. For Azure, the VNet has been added into the resource group. And what is needed is the name. So Brainboard has this cloud knowledge, and this is extremely helpful. Let's call it design first as well. Here, and I give it maybe the same Azure space as the VPC in AWS. Right. Now I keep going. I can say, okay, I need subnet exactly as I did in AWS. And here call it design first. And for the prefix, I take the same one as the subnet there. All right. And I can keep going. I can say, okay, now inside my resource group, maybe I need an application. So my application, for example, I'm going to use an Azure function. So I just type function here, function app. And I can choose from, for example, here, this function app. And I can see that the function app needs a service plan, storage account key. I can say, okay, I need service plan. I just pick the service plan from here and add it into the design. So I'm going to put it here. And design first. And for the OS type, let's pick Linux here, for example. And from the SQ, I can say, okay, these parameters, I don't know them by heart. I need guidance, like how can I know what should I put here? We thought about this, and you have access to the documentation here in real time. You can say, okay, I need to access this specific resource in from Terraform and understand what's going on and understand what are the parameters, read them. And you can see here, these are the SQ names that I can use. And you can pick, for example, P1 V3. Okay. I go here, I add it. I do the same. I needed the storage account. I'm going to put storage account, search for the storage account here. So I'm going to add it here. I can say, this is my storage account for the replication. If you want to understand what you need to fill, this is something that you can open the documentation and learn by doing. So Brainboard gives you like 95%. And if you want to go this extra mile and understand and learn why you are building it, you can open the documentation. And here you can put LRS or GRS. Let's put here standard for the tier. And for the name, let's call it design first. All right. So now I go back to my function. I said, okay, my function, actually, let's make it this way. My function needs service plan. I just search for service plan ID. So this is what I'm looking for. I select it. Brainboard again, depict the relationship between them here. This function using the service plan ID. For the name, I'm going to call it design first. And for the storage account, I just search for key. And here, Brainboard suggested from the exported attribute of the storage account, what is valid to use? It's not, I mean, you are guided. And for example, I'm looking for storage a key, access key. So this is the first primary. I'm going to use a primary. And for the storage account, it works the same. I'm going to select the storage account and put name because this is the name. The name here is needed. And I fill the information. The code updates in real time for me. And now I'm building the cloud infrastructure. Let's make it bigger here. to show you clearly the relationship. So here I can see what I'm building, and I build side by side AWS and Azure. I can switch into GCP as well and do it the same way. I can switch here. Let's do it. Let's switch into GCP and put like real multi-cloud here. I'm going to put the region in GCP, and inside the region, I'm going to choose a compute network. All right, so I'm going to put the compute network here, and inside the compute network, let's call it design first. And inside the compute network, I need subnetwork. So I'm going to just here subnetwork. I'm going to add it inside the compute network. And as you see, Brainboard detected, even for GCP, we like every cloud provider, we have the logic of the cloud provider. It detected that this subnetwork has been added into the network, and now I'm going to give it the same CIDR range as my VPC and VNet, and I give it a name like SNet1. All right, and I have my code generated. Then I can say, I can split. Okay, Azure things goes to a specific file that is called Azure. And AWS things will go into AWS file. I'm going to call it, for example, AWS. And GCP things will go into GCP file and group, call it GCP. So now you have, if I click here, I have Azure.tf that contains only Azure resources. I click on AWS here. It's going to switch into AWS.tf, contains only AWS resources. I click on GCP. It's going to switch into GCP.tf and contains only GCP resources. So you have, this is the power of having the design that matches 100% what you can do with the code and the generated code, and you have full control over it with all what you are used to do and beyond that. And this is the second part. Like, okay, I'm a building. How can I make sure this code is valid? How can I make sure that you talked about the CI/CD embedded? And by the way, you see my colleague Stark here is connected. This is collaborative platform. Like we can all get connected into the same platform. I'm seeing that he actually selected here AWS. And for example, I can see for any action, all right, now he's selecting Azure resource, and I can see what's going on. And by the way, if he does any modification, I can see live design and code of what's happening.
What is interesting, Shafiq, is that you live in New York, I live in France, and I learn how to use Brainboard, and I learn how to design directly by the collaborative aspect of Brainboard. You always taught me how to build and how to configure resources thanks to the collaboration.
Yeah, this is
this
is a very good point, because we are geographically into two different locations, and we have been building things together for like so long now, and we have been doing it through Brainboard all this time, and either building real use cases or learning or doing like webinar like this, sessions like this, and demos like this. It's a great opportunity. And I can see here also that Benjamin, one of our colleagues, is curious about what you are doing, so he's joining to review what we do. And yeah, and the second part, which is, okay, I want in the same platform, I need my CI/CD here, because I want to make sure that all the tests, that what we were talking about here, yes, here, the feedback loop, I want to have it in the same platform that I can test. All right, so here I can put here my default workflow. And I can say, okay, I start with code validation. This is what we advise even our customers and users. And you can see you build a pipeline visually. You don't need a learning curve to build pipelines, because what matters is that you understand which stage will run before or after which other stage, and what are the actions within the stage and the dependencies and so on. So it doesn't make sense that you go deeper into like building it by hand if you can design it visually quickly. And you can see we're going to do it super quick. And here I can, if I need approval for this task, I can put an approval. All right, so once the code is valid, we can trigger the security tests. And we highly advise you, and this is something that we have been advising our customers also, is to always check the security of the infrastructure. We have a lot of open source tools. It's free, so do it. Security check here. Let's call it security check 1. You can add, for example, general scan, security check 2. And we are planning to add more security checks into this. And in the same stage, you can say, okay, I need, for example, OPA policies. You just type here, like, for example, my networking policy, and I just type in OPA here, like this is, I put my Rego, let's put Rego 1, and here call it package Brainboard. I'm going to put here the close, deny, or whatever the decision, and use it later. Call it, for example, the package Brainboard, and I want to base the decision on the deny. This is a very powerful OPA, by the way, very powerful policy as code tool that you can use and take advantage of. And you can add, okay, I need, for example, pricing. I need to understand the cost of the infrastructure. You can combine it as well in the same stage. You can build as many. For example, we just need API here. And then you can also, like, once this is done, all the checks are done. Now, if you go back here, you need someone to review, validate, and approve. You can just send them a notification. I picked the email, but you can combine both, like here, ask for review. And let's, for example, call the security team to check the infrastructure, or DevOps team, or whatever. Ask them, like, please review the infrastructure. I mean, you can send an email or a notification with Teams or Slack or whatever. So you need the URL, the webhook, you need the configuration. After that, you can say, okay, once I have the information here, I can now, so the one who checks the infrastructure and reviews the infrastructure, she or he has all the information needed. So they can look at the design, understand it, they can inspect the code, they can see the output of the execution of everything. And then now you can say, I confidently deploy the infrastructure, apply, but here I'm going to ask an approval. So I'm going to ask, for example, Tarek here for an approval. And so only Tarek will be able to approve this infrastructure. Even me, who is creating the pipeline, I will not be able to approve it. And let's call it here deploy on approval. And we talked about integration also with the different tools that you have. You can even here, once the infrastructure is deployed or before the infrastructure is deployed, you can publish into Git. You can do the pull request into the Git repo of your choice. We support all Git repos. I mean, the major Git repos, GitHub, Azure DevOps, Bitbucket, and GitLab. You can select the one you want to build, for example, Azure DevOps. You select which project you want to push this code to here based on the credentials that I put. And now, let's call it, I can put it into a specific folder or branch. This is, for example, here, design first demo, and in the title, design first. Now, part of my pipeline, and we are the only tool, by the way, that allows you to do pull requests after the checks are done. So which means I can remove here the deployment. I'm going to put it after. So I do the pull request, and then I deploy the infrastructure. So you can play with it the way you want. And now I'm going to trigger the pipeline and have a complete vision, like 365 view of what's going on into my within my infrastructure, and I'm able to take the right decision. Hopefully, we will have some errors that I will show you what the output is. And actually, we execute Terraform. There is nothing hidden. It's we show you even the commands that we use to and their output. So here I have, yes, I created some variables for which I didn't put values, which is correct. And here I go back to the design and I know what to fix. I can say, okay, I created some variables. Or maybe let me delete this once. Let's take just Azure to remove it. Remove this once. All right, I'm gonna put and remove these two variables here. And just to show you complete, all right, this here I have all the information. That's good. And let's see successful execution. And so here, once every stage depends on the previous stage, but you can, this is like by default dependency that you can change. You can say, no, I don't want the stage to be stopped by the other one, but I want it to be to have a different strategy. I can see here, okay, this is the storage account needs only lowercase. So let me here open a new tab and fix the errors. And this is what this shift left is about. Yes, and let's open here. Yes, one of my colleagues told me that I said 365 is 360-degree view. Thank you, Jeremy. You are behind. I love it. All right, so here in the Azure, it's in the output here, it's the storage account. The storage account doesn't like the capital letter. And I promised at the beginning, I said, I will show you something that the team is working on. Maybe now that is the time. What we are working on, guys, is to enable this code that is till now is read-only. This code is automatically generated by Brainboard every time you build a cloud infrastructure. We are planning to open it. So here, I can now enable, this is in an alpha. This is an alpha feature, is in alpha mode now. If you are interested and want to play with it, ping us, we'll open it for you. So you can reach out to Tarek or me or Brainboard team on LinkedIn or whatever the platform. And here I can switch, and now I can edit this code and call it. So quickly change it and save it. So now it's design first, and I'm going to trigger my pipeline again here and see what's the issue. Hopefully this will work to see successful implementation. And Tarek, do we have any questions from the community we go through while waiting for the output?
I think we're good. We answered to all of them. We answered about there is one question maybe about the templates that we are going to show them after that, how they can use the templates directly, or how they can convert into reusable templates their own cloud infrastructures. Except the templates, I think there are not a lot of questions right now.
Okay, absolutely. Great. So here I have the output. This is successful. So now I have the security check, and I can see this is, I have two critical issues, and I can read them. I can see, go through the output and see and read. Okay, this is here the issue. I know, I understand that I'm using an insecure TLS version. And by the way, you have the link to the documentation. So you have, it's an ugly blue, but the link is here. I can put it here and understand why it's critical. What is the insecure example, what I'm doing wrong, and how can I fix this issue here? Now I can go to Brainboard, and this is in the storage account. So I'm selecting the storage account here and look for TLS version. I'm going to put it this way. So the code will be generated for me like this. And so now about this is like, okay, I have the feedback loop. I fix everything. Once it's fixed, so I'm going to deploy the infrastructure with the approval and everything. And I have history of all what happened to my infrastructure with different pipelines, with the view and who did what, and the output of every task. So now here you talk about the template and how we can capture everything within a template and not reinvent the wheel. So here, for example, I can say, okay, this is a repeatable pattern, and I want to add within it my naming conventions. So let's take this one here. And for the naming conventions, I'm going to add, for example, things that you are used to do maybe with Terraform. I'm going to add a prefix, then add, for example, a string, call it design first, then add another variable called var. Let's say environment, just then another variable var.scope or something, anything that maybe this is a syntax, or use Terraform functions. They are powerful. Use the index, the for each, whatever you want to include here. You save it. You have the That's what I'm doing wrong here, which is, okay, let me fix this one here. Let's save it. All right. Or, oh, yes, this one, it should be, yes, curly braces, my mistake. Okay, now the code is correct and the syntax is good. And now I can say, I want to capture this. I want to put it into a template. I just click here. I'm sorry, here. And now I'm going to either create a public template or put it private. So here, when I put it private, let's call it design first application. I'm going to publish it into the templates catalog. So here, once it's published into the templates catalog, how the life of the other engineers, or even you, if you want to use it, looks like, you can go here. Let's select a different project. For example, here, a different environment, let's say production. And now I can go into the template and search for design first here and clone this architecture. And this is so powerful because you capture your use cases into a system with your naming conventions, with the once approved, and you integrated all the security checks and costs and so on. You put it into a template that anyone can just pick off the shelf. You will be building actually your own catalog of templates. And this is you have the public one, and you can add documentation to it. For example, if I pick this architecture here, I have the complete documentation with it. So this is something that you can build if you want to add documentation to it. And you have them. You have all the requirements and how to use this infrastructure, which means you will be bringing not only a system, but also awareness and visibility into the things that you build that people can read and understand and use them as easy as possible. So this is in terms of templating. And we talked also about, like, for example, in terms of scaling, there are a lot of things that you can do. We talked about templating. This is just one of it. And the templating actually goes into even the templating of the pipelines. You can say this pipeline is now an approved one. It's a complete stack. It has all the information that need to test, all the tests that we need to perform. I can now create a template out of it, call it design first. So here, and now this pipeline is a template. It's going to be here in the templates, and I just pick from here and use it. Okay, let's. Yes, Tamak?
There are one comment and one question. The first question is, do you have a tool to convert the diagram to a YAML template?
No, we do not support YAML. We support only Terraform for now. We are planning to expand to other languages like Bicep, Azure RM, or AWS CloudFormation, but we do not generate YAML out of it.
The comment was from Mijil. I hope I pronounce it well.
Yes.
It's a good idea, but the tool seems a bit hard to use, especially when the infrastructure is already complex.
Yes. So this is actually maybe the question here, the background of the question is, when the infrastructure get complex, the diagram got complex. And actually, let me show you something here. This is multi-subscription that I have. Okay, I have a multi-subscription landing zone in AWS, in Azure. The infrastructure is not that complex, but a little bit. But you can actually, you have the power of both works. You have the power of the diagramming and the power of the code combined in one. So, and actually, this is a very good question in terms of complexity, because when it comes to complexity, is it complex because you have a lot of resources? Or is it complex because you are depicting the same resource multiple times? And here, actually, you can use the mechanisms that you can use with Terraform. Let's say, for example, here for the container app, and they have 10 containers up in the design and link to different components. Actually, you have the same mechanisms as Terraform. You can say, I want to build like I want to use a counter for each, which, for example, I'm going to create 10 or a variable var.container apps. And now inside, in the configuration, I'm going to put, for example, here for the name, I'm going to combine this variable here with the count index. So which means if I had 10 components, I can replace them with 1. And this is actually what we wanted to build. And you can see that the count relies on a variable, and you can see it. And this is exactly the first thing that we thought about, is that the diagram can get complex very quickly, and we wanted to integrate the native Terraform mechanisms within the diagram to simplify it. So that's why the question is like, are you creating the same things over and over again, or it's just the infrastructure is big? And when the infrastructure is big, actually, the application has been optimized to work smoothly, even with the increasing number of resources. And actually, you can, for example, I'm going to replicate the entire here, this stack. I'm going to duplicate it here. Let me move this one like this. And you can see, like, even complex, I can move it here. And now I can put it into separate files. And you can like map what you have in the design, the groups that you have in the design, and the groups that you have in the Terraform code. So for example, here, I'm going to create this one and call it, for example, design first. So now Brainboard will put all these resources inside a file called design first. Maybe if you don't want to see this design for this component, you can close them here. So they will be closed. For example, you need to work on the connections, but you can fold and unfold components, or specific one. You can say, okay, this contains a lot of resources. For example, let's take, for example, okay. I'm sorry. Yes. Okay, if you have containers that contains the resources, and if you want to fold and unfold them, you just here fold to reduce them, or unfold them to see what are the components inside, whatever the number of components you have. And you can see here, I have like this architecture about like 86 components, and you can go deeper with the loops and so on. The second part of the infrastructure, actually, when the infrastructure is complex and bigger, this is not a good sign from the Terraform point of view, because the Terraform best practice is to always keep the infrastructure small because of the Terraform state, the TF state. If the infrastructure is big, it means that the TF state, the refresh in the state, may take longer. It means also that the blast radius is big. If you change something, you can impact other things. It means a lot of things. So that's why even Terraform advises the users to keep the Terraform states smaller and architecture smaller, and and combine them. And you have also the possibility to use modules. You can say, okay, so I'm really going deep into explaining how you can simplify the infrastructure, and even if it's deeper, you can say this component here, all this part is, I don't want to see it. I want to use a module. So you just pick a module. Let's take, for example, Terraform VNet module. I just give to Brainboard this first, and here I'm going to import it. Call it VNet module. So now I have my module, and instead of having the complexity of these resources, I'm going to delete this one here. Okay, delete it with everything, and delete these two as well, and add the module. So you can see here that Brainboard added the module, created the module syntax, and now I have all the information about the module that I can fill and create the structure. Like, for example, I need, so let's put some DNS servers here, like server 1, or maybe IPs. It's very, like, let's put IPs here, like 8.8.8, and here I'm going to put 1.1.1. 2.3.4, and so Brainboard understand the modules natively and work with them. And actually, Brainboard understand even the interaction between foreign object, the module that I just imported from internet, and the native resources. Like if I drag and drop this module, you can see here the configuration. Inside the resource group, Brainboard understands this action and update automatically the module. You see? So that's the like all the mechanisms that we put in place to make the infrastructure, even if it's bigger and complex, simple to use, and you can slice it with all the mechanisms that you already know and use in Terraform, but taking it to the next level.
That one question about the module and one question about the cost. The module is it possible to work with custom modules and import them into Brainboard? I think this is what also we showed right now, right?
Absolutely. Custom modules, let's say, for example, you have your modules hosted in your Git. You just specify which Git connection you want to use, and you put the URL of the module and use it. And actually, you can even import, if you have even local files in your laptop, you can import them and create a module. So this is, you have great flexibility of modules. And this is what we mentioned here. Terraform modules are first-class citizens. So everything about modules is present in Brainboard.
The second question was about the resource billing. Do we have a resource billing comparison option between multi-cloud in this Brainboard dashboard?
We do not have this is a very good question, by the way, and very good suggestion for a feature. So we do not have it in the design, like to compare the resources, which is which, and how much does it cost every resource. This is something that we have in the pipeline. So for example, here, let me switch into another architecture, which is, for example, I have one here, landing zone for Azure. I can see in the pipeline, for example, here, how much will cost me this infrastructure. So you can see that this infrastructure will cost me $1,577, and I have the breakdown of every resource. And we use infra cost. So it's an open source tools, one of the most used tools for cost estimation. And hi to our friends from InfraCost. So yeah, you can use it, and we use it natively. It's natively integrated in Brainboard that you can have. You can see how much does it cost, but you do not have it in the design.
We had one question about CloudFormation. Do we support CloudFormation?
Yeah, no, we do not support CloudFormations. Actually, this is what I said. I think someone else asked about the YAML, and I said, yeah, we only support Terraform. We are planning to expand to other languages like CloudFormation and Azure Bicep, but for now, we only support Terraform.
And for now, we don't have other questions.
Yeah,
one question that I had was, you spoke about managing multi-cloud, no, not multi-cloud, but multi-environments.
Yes.
You showed one way to do it was with the templates. Maybe show really quickly how maybe you could do sync and what we call sync or clone.
Absolutely, yes. We are right on time, but we can take a few minutes to do it. So this is something very important and helpful and powerful at the same time. So let's say, for example, I have this infrastructure here within, I'm in the dev environment, okay? And now, let's say I want to build staging or production. So I just go here and select the target environment. Let's say production. And now I have the possibility to either create a standalone copy, just a copy of the existing infrastructure, or what you are referring to, Tarek, is syncing both architectures together. This is so powerful. I can now sync both architectures. So now Brainboard will create a replica in production. So here, all right. Now I have the replica in production. And I can see here, you have a new button that will appear that shows you all the replica of the infrastructure. And one of the use cases could be disaster recovery as well. Like you want to build your disaster recovery strategy, you can use it as well. And now, which means, so here I'm in production, which means any modification you do to the design. So let's move here and add, for example, let's add or not firewall, I already have a firewall. Let's add a front door something. Like for example here, front door. I added here, and in the name, I'm gonna call it front door name. So Brainboard will create automatically the variable called front door, for example here. And this variable, let's put type string, and I'm production, I'm calling it production. This is just an example to show how it works. So now if I move to the older environment, which is dev, I'm supposed to see the same changes. So here I switch, I have the same changes, the same, yes, here's the front door, the same changes, the same configuration, just the value of the variable that changes. If I look for front door, oops, front door here, I'm going to put dev in the name and update it. And that's it. So my environment are synced. They share the same design, the same architecture, just the values of the variables are different. And this is what people are doing, playing with the TF vars. So here I have the TF vars, for example, here dev. Don't worry about these. This is demo environment, so the passwords are just for demo purposes. And if I switch into the other environment, which is production here, I have the front door. You can see here production value. So this is the way you build what is called synchronized environment within Brainboard. So you have the same infrastructure across multiple environments, production, dev, staging, QA, disaster recovery, whatever. That you do not repeat yourself. You do one change is automatically replicated, and the values of the variables are different. And you have a great control of the deployment. You may deploy development and not production. You may develop staging and not QA. So you can choose which one will be deployed, even if they share the same architecture. We are on time, Tarak. That was a great session. Thanks for everyone for joining and asking questions. If there are questions that we didn't answer, or guys, are you want to reach out to us to have a dedicated demo for your team, or you want to understand more how Brainboard can help you and how we can help you to successfully build a cloud infrastructure, we are ready to and happy to help. Just ping us. Either, as I said, Tarak or me, or reach out to a Brainboard team. And yes, it's really nice, and hopefully we'll see you the next month. We're preparing another session for the next month. Yeah, meanwhile, take care and enjoy the day.
Thanks a lot, everyone.
Yes, Bye. Take care, Tarak. See you.
Bye.